Can we have a 10-bit register in a 8-bit microcontroller? Answer is no. If that is the case, what they will do? See, actually, ADC gives the converted result in 10 bits. See, I have 8 pins in this microcontroller. Those 8 pins are used for digitizing 8 analog inputs. Let us say
Yes, sir.
I have a voltage pulse, which is a 5-volt voltage pulse. I give that to this pin. When I give that to the microcontroller, let's say everything is working fine. So it has digitized. Once it's digitized, ADC will get 10-bit result. But this microcontroller is an 8-bit microcontroller. How to store 10-bit result in an 8-bit microcontroller? Come on, tell me. We need 2 memory location, because it is not like we cannot store it. We have to use 2 memory locations of size 8. In one, we will store 8 bits of ADC result. In another location, we will store only 2 bits of the ADC result. That is
Correct.
not stored before. Understood?
Yes, sir.
Let's say I have a memory location 1000. I also have a memory location 1001. Right. Now the converted result by the ADC is 5. 5 in a by result is number 5. Converted result. They convert this as a 5. This voltage value is 5 volt. So it is digitizing that to 5. When it digitizes that to 5, computer will not have the 5 like this. It will have the 5 in 10 bits. How can we write that 5 in 10 bits? So we have to convert that into binary. So 5 is just like 101. That is what? 3 bits are enough to represent 5. But what about the remaining bits? Remaining bits are set as 0, default 0. So my result that is given by the ADC is like this. So I am grouping to understand as nibble right now 4 bits. Actually, they all will be consecutively 10 bits. So 4, another 4, another 2. Totally 10 bits. Agree?
Yes,
This
sir.
is a 10-bit RAM. I represent 5 in 10 bits. Correct only, no?
Yes, sir.
Now we have to store this in some memory location. So, because only then we can handle it. Yes or no?
Yes, sir.
Only then we can use that ADC value to comparison other stuff. Okay, understood. Now, the question is, this is an 8-bit microcontroller, no? They have to store this 5 in the memory. To store 5 in the memory only, they use this register ADC. Let us say, I say AD memory location 1000 as AD result high. And memory location 1001 is named as, these are just for example I am saying, this is called as AD result L. These are the name used for this memory location. So moment the ADC convert the result, it should store it. If this bit I am talking about, there was an ADC ADFM. If this bit is set to 1, they will store the result like this. So this AD result L will have 8 bit from this, because it is an 8 bit. No, from the result we will take least 8 bits. What is the least 8 bit? Least 8 bits are 0, 0, 0, 0 and 0, 1, 0, 1. That will come to AD result L. Yes or no? Because total 10 bit we are dividing the 10 bit into two sections.
Yes, sir.
In that, because this AD result L can store only 8 bits. That's why we take 8 bit from the LSB of that ADC result to this one. What we have remaining 2 bits, right?
Yes. Yes.
Those 2 bits I will come and store it in address H. So when I store that in address H, I will have 0, 0. Okay. Totally 10 bits. As we have achieved the 10 bits, we have stored them. But address H is also 8 bit in size.
Yes, sir.
Among those 8 bits, how many bits we used?
2 bits.
2 bits. Remaining how many bits are there?
6 bits.
6 bits. Those 6 bits are don't care. Don't care means they will remain in 0 only.
Yes.
Understood?
Yes, sir.
That is what they are saying. So when you set this bit to 1, it is right justified. Right justified means, see here, the result is from the right justification. If you result entire result in sequentially, so your result is right justified. Yes or no? If I write the entire 16-bit result, so you put x x x x x x 0 0 and 0 0 0 0 0 1 0 1. If I see both the register values together in a single view, all 10 bits are right justified. Yes or no?
Yes, sir. Right justified means it's we are reading from right. Right.
Actually, we are starting representing the number in the least 10 bits of total 16 bits.
Yes, sir.
Got
Correct.
it now?
Yes.
So left justified means what they will do, they do like that. They will make the same thing. Let me explain that here. If we set that bit to 0, it is stored like this. In 0x 1000, and we have 0x 1001, right? So here you just understand this is an address L, this is address H. So the result is stored like this. First, they ignore 6 bits in LSB result. So the total result that we got is this, no? So in that they will only put 0 1. So in this entire result, 2 bits are only encoded in the address L. So remainings are don't care, meaning they will be remain in 0. After that, in H, ADC result H we have, no? There they will put remaining 6 bits. What are the remaining 6 bits? 0 0 0 0 and 0 1. So
0.
if we put entire thing together, the result of these thing together, we will have the result like that: 0 0 0 0 0 1 and then 0 1. Here one thing is missing
I think 2 zeros need to be added in this.
in this one right now.
Yes, sir.
One, no, correct only.
Only 6.
6 we have, no, 6 we have. Oh, 10-bit result, no.
Yes.
This one 2. If that is the case, we have to additionally add 2 zeros.
Yes, sir. In the after before in the lower nibble.
I understood. 1 minute. Let me cut this.
So we got a 5 volt in one of the pin and So these registers they connected this digital 5 volt to sorry, analog to this digital output,
5
right, sir?
word. Yes, yes. If ADC is activated, if it is activated, this will happen. If ADC is not activated, this conversion will not happen. Understood?
Yes, sir.
So if now I can write like this 0 0 10 bits, no, totally 0 0 and then 0 0 0 0 and then 0 1. Agree, correct now? So
Yes,
6
sir.
bits totally. Here we have 8 plus 2, 10. So the result now, if you look at the result combined together, now if you group like that, it will be something like this. 0 0. This is, let me do the exercise one more time. I just write this result in a straight line 0 0 and then 0 0 0 0 0 1 and then I combine it here 0 1 and I make mistakes 4 to 6, but we are grouping them like this, no. So first let me 0 0 0 0, that is I grouped them to 4 bit and then 0 0 0 0, then 0 0 0 1 and 0 1 0 0. I can make this as an XX and then XX XX. If you look at this, the result is left justified, this side. Got it now? 10 bits are here. Agree?
Yes, sir.
That is how it is. So that is what they are trying to say. Right justification, less justification. Now you understood, right?
Yes, sir.
Okay.
So these 8 pins for input, the 8 pins are configured or only like from the single pin we are taking?
Brilliant, understood. There is something like these are called as 8 channel. You can select the channel while you are doing conversion, whether you are going to digitize from RA0, that means channel 1, or channel 2, channel 3, that we will study. That is coming. That is the next step. Understood?
Yes.